Prestressed concrete, PC, industry. Prestressed concrete, what is PC? While you may think PC is an abbreviation for personal computer, PC in the world of civil engineering and construction refers to prestressed concrete. Remember this term, PC, as it is much easier to say than the tongue-twisty prestressed concrete. We assume you are all familiar with reinforced concrete, RC. Reinforced concrete is concrete that has been made more robust by adding steel reinforcement bars. Cracks can still occur, however, if a very large amount of force is applied. Prestressed concrete, a type of concrete that is prestressed through tendons, was conceived as an even more durable form of concrete. PC is used in bridges and many other structures to counteract tensile stresses in the component parts. In this video, we will be introducing you to some of the most common PC structures, alongside photos and a brief description. PC characteristics. First, we will explain the characteristics of prestressed concrete, PC, compared to unreinforced and reinforced concrete, RC. Unreinforced concrete, shown in the upper left, is very weak against tensile forces, and cracks under load. While reinforced concrete, shown in the upper right, has steel bars that are designed to resist tensile forces, some cracks are still inevitable. Prestressed concrete, PC, shown in the lower left, is stressed ahead of time, with compressive stress applied to tendons in the concrete, to prevent cracks from occurring in the structure. Tendons here refer to the steel tensile material used in the prestressing process, called PC steel. Pre-tensioning system. There are broadly two ways to prestress concrete. These are the pre-tensioning system, in which the tendons are pulled before the concrete hardens, and the post-tensioning system, in which they are pulled after the concrete hardens. These photos show the process for the pre-tensioning system. The PC girders are fabricated at the factory, then transported to the site on trailers, and installed on the abutment using a crane. PC components made using the pre-tensioning system are also called precast components, referring to the fact that they are fabricated in advance. Recently, the industry has been working together to develop more of these precast components in order to improve productivity, and provide safer and higher quality social infrastructure. Post-tensioning system. Next, we will explain briefly the post-tensioning system of prestressing, using a typical PC girder as an example. First is 1. Assembling the rebar and sheath. Before the concrete is poured, the sheath is placed in the area where the tendon will be placed, and the tendon is passed through the sheath. Next, 2. The wooden form is assembled and the 3. Concrete is poured. After the concrete hardens, the wooden form is removed. In 4. Tensioning, the tendon is pulled at both ends of the girder. As the amount of force gradually increases, the tendon is pulled and stretched, and the girder is compressed and shrunk. While in this state, the tendon is fixed at the ends of the girder to prevent it from returning to its original state. This causes the storage of tensile force, tensile stress, in the tendons, and the tensile force compresses the girder via the clamps. This subjects the girder to compressive force, which is how PC girders are created in the post-tensioning system. Structures made with PC. PC structures are highly durable due to their use of piano wire, high tensile steel, and high-strength concrete. Structures made with PC include bridges, tanks, disaster prevention facilities, and buildings. It is also used in a wide range of other applications, such as offshore structures, underground structures, pavement, and for reinforcement purposes. The appeal of PC is how much flexibility it allows in terms of design, and its ability to create slender structures. Seeing these beautiful forms blending into the landscape is enough to fill you with a sense of deep accomplishment and satisfaction. PC construction involves many people in the processes from design to construction, and is the perfect industry for those who wish to create something that will remain on a map over the long term. 1. Bridge structures, precast PC girder bridges. First, we will show you some examples of bridges, which are the most common application for PC. The scale of a bridge varies depending on the distance, span, between the piers that support the girders. Bridges made with PC can have spans as short as 10 meters, and as long as about 300 meters. PC bridges come in a variety of structural types, starting from the simplest PC girder bridges to PC cable-stayed bridges and arch bridges. The way in which the PC is used, PC steel placement method, differs depending on the structural type of the bridge. The photos show the fabrication and construction of precast segmental girders for the Tsuchiya Owashi Bridge, Aomori Prefecture, the Vunosaki Bridge, Akita Prefecture, and the Okabegawa Bridge, Shizuoka Prefecture. Bridge structures, PC bridge, post-tension girder, cast-in-place girder. Methods of fabricating PC girders on-site include pouring concrete into shoring built up from the ground, then pre-stressing the concrete, as well as a method called overhang construction, which utilizes a special construction vehicle, called a wagon or traveler. The photos show the overhang construction method using a special construction truck, which erects the girders by hanging out over the structure at points symmetrical to the pier. This shows concrete being poured in one block through the overhang construction method. 2. Civil engineering structures other than bridges. Precast PC components are being developed and used for the purposes of eliminating traffic obstructions and speeding up construction in urban areas. The photo shows the Tamatoshi monorail, which has a maximum span of 21.2 meters, and is made using PC hollow girders. Civil engineering structures other than bridges, airport-related. PC pavement is used for roads, airports, container yards, etc., and as PC ground slabs. These range from large-scale cast-in-place structure to precast products. The photo shows the apron pavement at Haneda Airport, with a PC pavement area of 307,555 square meters. Civil engineering structures other than bridges, disaster prevention related. PC rock sheds and PC snow sheds are structures developed for the purpose of preventing falling rocks and avalanches on roads, and are typically made with precast girders using the pre-tensioning system. The photos show a PC rock shed of the reversed L-shaped ramen structural type, and a PC snow shelter and PC rock keeper of the three-hinged arch structural type. Civil engineering structures other than bridges, road-related. While PC pile is the most commonly used component in underground structures, PC is also used in structures that are buried in roads. This includes small box culverts that are used to cross roads, and joint trenches where power and telecommunication lines are buried underground. These are often made with precast components in order to help shorten the on-site construction process. The photos show the construction of a precast PC box culvert. 3. Buildings. Structures other than bridges in which PC is commonly used include buildings. Buildings are comprised of columns, beams, and floors. Beams can be made of PC components much like bridge girders, and precast concrete slabs, floor slabs, are used in ceilings, or floors. The photo shows the Hyogo Prefectural Awaji Medical Center during construction and after completion. The building is comprised of 8 floors above ground, 2 tower floors, with a total floor area of 35,333 square meters. Building structures, PC jetties, evacuation facilities. PC jetties are an example of where PC is used in marine structures. There are two types of mooring facilities: bridge structures and floating structures, box type. The photos show the Raosu fishing port, building area of 15,750 square meters, and the Kakagawa City Tsunami Evacuation Facility, evacuation area, 200 square meters. 4. Container structures, tanks. The next most common use of PC is in container structures, tanks. There are many different types of tanks, depending on their content. Examples include silos for grain storage, water storage tanks for water supply, and LNG tanks for municipal gas. The photos show Nozawa Water Distribution Reservoir Number 3, which has an internal diameter of 43.9 meters, a height of 8.2 meters, and a capacity of 10,600 meters cubed. Container structures, egg-shaped tanks. One tank in particular that has attracted considerable attention in recent years is the egg-shaped tank for sewage treatment. With typical cylindrical tanks, PC steel is placed mainly in the circumferential direction. In an egg-shaped tank, however, there is tensile stress in both the circumferential and vertical directions, making the structure more complex, with PC steel placed both horizontally and vertically. The photos show the egg-shaped tank at the Ginowan Sewage Treatment Center, which has an internal diameter of 21.7 meters, a height of 32.8 meters, and a capacity of 6,700 meters cubed. Prestressed Concrete Construction Industry Association. Objective: to train key technicians who will serve as a link between technology and skills, in order to ensure the smooth execution of PC construction, and to pass down traditional techniques. Members: 201 member companies and 29 supporting member companies. Business description. 1. Collection of materials related to the advancement and improvement of prestressed concrete construction and PR, educational efforts. 2. Education and training of technicians engaged in prestressed concrete construction. 3. Liaison and consultation with the Japan Prestressed Concrete Contractors Association and other affiliated organizations. Here, we showed you what PC can be used for, alongside photos. What did you think? While you may have seen some structures you are not familiar with, we hope this has made you even just a little bit more interested in PC. We are looking forward to the day when we can work with you all in Japan, in the many PC-based projects there are in this country.